Rightio, another really good question here about these pesky little asymptote questions. So this one here, for the following functions, determine the equations of the asymptote. So let's just have a look at one here. We'll take, I don't know, let's take b to start off with. Why not b? Y equals 2 minus 3 divided by x plus 1. So we know these are the hyperbola functions. They've been shifted around a little bit. Our regular one, just 1 over x, or a reciprocal function, ends up looking like this, doesn't it? And we could very quickly see what's happened to transform this function. It's been multiplied by 3, and in fact negative 3. So multiplying by 3, stretching it vertically. Can't really see a great deal of difference with this sort of graph when you stretch it vertically, but it's going to be steeper. Negative 3 means it's going to turn upside down, doesn't it? So instead of being that way around, it's going to, the blue bit, oh, I've lost where my cursor is. There it is. That bit there is going to turn upside down. This bit here, reflecting in the y-axis, is going to be up there. Okay, so a negative reflected in the y-axis. Adding a number to x shifts it 1 unit to the left. So it's going to come back 1 unit to the left. It's going to be flipped. And then adding 2 moves it up 2. So I could actually get a fair idea of what it looks like just by understanding the transformations. And that, in fact, is enough to be able to sketch it. If you know what the initial one looks like, with the axes being the intercept, so this is, of course, y equals 1 over x. When we come over here and try and sketch this function that we're talking about, 2 minus 3 over x plus 1, so it's shifted 1 unit to the left, so you can see this intercept is now x equals negative 1, sorry, this asymptote, and intersects there, of course. The y asymptote, the horizontal asymptote, the one going through y, is going to be y equals 2, because I've done a vertical shift of positive 2. And because of the shape, we know that it's been reflected and then multiplied by 3. We're going to have it looking something along those lines. I'd probably want to calculate those intercepts first if I was going to sketch it, but that's good enough to get an idea. And so you can do the asymptotes just by thinking about the transformations of the graphs. Let's also think about them mathematically though. I have a vertical asymptote when x is undefined, when the function is undefined. So what makes the function undefined? Well, remember, there are only a few things that we're really not allowed to do in maths. Square rooting negative numbers, finding the log of a non-positive number, and dividing by 0. Clearly, with these sort of functions, it's dividing by 0 that's the problem. And so x plus 1 cannot equal 0. X is not allowed to equal negative 1. Therefore, my vertical asymptote is at, or is the line, x equals negative 1. What about the horizontal asymptote? Well, again, since 3 divided by x plus 1, so you can see here this second part of the equation, that can never equal 0, can it? 3 divided by a number. Well, if the number that I'm dividing by is bigger than 1, I'm going to end up with a number smaller than 3. If the number I'm dividing by is a fraction, so 3 divided by a number smaller than 1, I guess you can have fractions. 3 over 2 is a fraction. But if the number I'm dividing by, if that was between 0 and 1, well then 3 is going to increase in size. But it can't equal 0. The only way a fraction can equal 0 is if the numerator is 0. And clearly it's 3. So since that can never equal 0, y can never equal 2. So therefore the horizontal asymptote is y equals 2. And that's all there is to it. Let's have a look at one more of these. Let's have a look at 3x take 1 over x plus 2. And I want to do it a couple of ways because there is the shortcut way and the way that I think gives you a better understanding, at least in terms of being able to picture the graph like we did the first time we went through that one. So here we've got f of x equals 3x take 1 over x plus 2, and I want to just find the asymptotes. Well, obviously the vertical asymptote when x plus 2 equals 0, so x equals negative 2. that would be my vertical asymptote. And again, that makes sense. It was a shift to the left. Now, what about this thing here? It's not set up in the same nice form we had the other one in, where we had the constant plus or minus a fraction. So we can still do that calculus. We can still get it in that form. How would I get it in that form? Well, I want to make it so that this fraction would reduce. So instead of having 3x minus 1, I'm going to have 3. I'm going to write this as x plus 2. It's a little bit like the idea behind completing the square. We're going to get it into the form we want by just changing it a little. Now you can see I've got a factor that's going to cancel, so I'll get a constant of 3 on its own. That's really important. But what else do we get out of here? Well, so 3 times x, I've still got the 3x, but I've now effectively added 6. 3 times 2 is 6. So I've got minus 1. I just need to subtract the 6 as well to make sure that now if I expand it, 3x plus 6 minus 1 minus 6 just ends up being 3x minus 1 again. Once I've done that, I can have 3 times x plus 2 over x plus 2 minus 7 over x plus 2. And quite obviously the x plus 2's cancel, so it's 3 minus fractional amount, which again can never equal 0 because the 7 can't equal 0. So I've got my horizontal asymptote is y equals 3. And we're done. A shortcut rule, if you really just want to know the shortcut, I think it's much more important you understand it, but just as a little shortcut, it's really just the ratio of these coefficients that gives you the horizontal asymptote. Here I've got 3, this is 1, so for when you've got ax plus b over cx plus d, horizontal asymptote is just the ratio of those coefficients, so it would be the a divided by the c. But I would rather you be able to rearrange it so you get a real understanding of what it would look like, what transformations have happened, and then you'd be able to sketch it. I hope that's pretty clear. Come and see me if you need just a bit further explanation on that. Keep up the great work.